our employees running to work, excited to use our shredder.
Today, Team Temu Jarvis will be talking about our biomass shredder. In this presentation, we will cover the main basis on how and why the shredder was produced and visually see it in action. Furthermore, we will talk about improvements to the project. So sit back, relax, and let us begin.
Alright, so for our project we had a specific problem description. So biomass is a renewable resource which must be reduced in size for efficient burning or composting. And untreated biomass can cause uneven burning, system clogs, and operational inefficiencies. And so the goal of this project is to design and build a shredder that is capable of processing this raw biomass into a more compactable biomass material. So our system must operate with a 1/3 horsepower motor that is provided to us, and the final shredder design should be able to successfully process biomass, and the solution in general just should be a practical one for our uses.
To help guide the design for our biomass shredder, we had to follow constraints and meet objectives, which included shredding up to wood chip sized biomass. In order to preserve portability, the shredder should weigh less than 35 pounds. To provide electrical power, we were going to use a 112-volt AC motor, as is standard in most wall sockets in the US. And to maintain safety for the users, we were going to follow OSHA safety regulations.
Okay, so here's some additional objectives and constraints when we were making our design. The first one was that our design had to work for the provided motor, which had an RPM of 1725 at 1/3 horsepower. Our shredder needed to have a viable output, so anywhere between dust to small shreds of wood, and it needs to be consistent in size so that it can be properly used in the briquetter. Our design needed to be cost efficient, so staying under budget, and ability to deal with a variety of input shapes and sizes, as well as materials. So twigs, leaves, wood chips, stuff like that need to all be shredded into the same size. Okay, so here's a quick video description of our final shredder design. You can see in the front that there is an input chute, that's the black thing on top of the shredder, and this is designed so that the user can put any of the biomass or shredding material into the shredder without having to risk their hands being anywhere near the blades. At the bottom of this is the output chute. These are basically all the components of the shredder. All the dangerous ones are covered in some sort of cover. So you can see on the right side of the shredder we have our flywheel, which is going to keep the shredder actually shredding. That's covered by a steel box so that the user is nowhere near the flywheel while it's spinning at full speed. On the other side of the shredder we have the chain, which is going to transmit torque to the actual shredder. This is also covered by a protective cover that is bolted down to the chassis, so it's not going anywhere, and their hand's not going to be anywhere near it. And then on the other side we have a safety switch, which allows the user to stop it at any time if something goes wrong.
So our final design here, we had 4 goals initially. We wanted it to be less than 35 pounds, OSHA safety standard compliant, work with 120-volt AC, 15 amp wall power, and be capable of shredding wood chips, roughly 1x3 by 1/2 inch pieces of wood. We were able to meet 3 of these. Sadly, we were not able to keep it under 35 pounds or less. However, this is due to the fact that we wanted to make sure it was super safe. We wanted to make sure that it would stick together, so we put extra steel on there to reinforce it, and nice guards to make sure you couldn't hurt your hand or anything like that. So that's why we weren't able to do that. It's still portable. It's just a little heavy. Maybe slightly cumbersome for one person, maybe best suited for 2, but definitely still portable by 1 person.
After testing and evaluating the performance of our current shredder, we identified several key areas for improvement to enhance its functionality, durability, and its efficiency. First, we plan to expand the shredder lengthwise to house more blades, increasing from the current setup to more than 6 blades. This will create a significantly larger munch zone, improving the throughput and shredding capability for larger or bulkier material. Next, we recognize that our current input system, a flat-facing opening, is not optimized for easy material loading. To address this, we propose adding an input chute. This chute would allow material to be easily and naturally funneled into the blades, minimizing manual effort and improving safety and efficiency during loading. Another critical input involves blade spacers. Currently, these spacers are 3D printed and have shown significant wear after testing, with some nearly falling off. For future iterations, we would replace the 3D printed spacers with steel spacers to ensure higher durability and long-term reliability during the extended operation. Finally, we identified that the small gaps between the blade and spacers are large enough for thin material to pass through if it falls just at the right angle. To solve this issue, we would fill in or redesign these gaps, ensuring that all material, regardless of thickness, is properly engaged and shredded, eliminating escape paths through the assembly. Together, these improvements will significantly strengthen the shredder's performance, reliability, user-friendliness, and pushing our design closer to a production-ready solution. Thank you.